Welcome back to Math. Section 1 is going to cover some basic rules. They include PEMDAS, the associative property, commutative property, distributive property, identities, and factoring. In math, operations are the actions that we do, and they usually come in pairs of opposites like addition and subtraction, multiplication and division. PEMDAS is a way that we remember what order to do the operations in so that we all come up with the same answer. And PEMDAS stands for P, that's parentheses, and there can be several different kinds. The curly ones, the more square bracket ones, and the real fancy curly ones. E stands for exponents. MD is multiplication and division. AS is addition and subtraction. So that means that if we have an expression that we want to work on, we're going to start inside the parentheses first. If there's two sets of parentheses, one inside the other, then we just work from the inside out. Then we do any kind of exponents. And then we do multiplication and division. In this way we work from left to right within multiplication and division. Same with addition and subtraction, work left to right. So here's an example that has two sets of brackets or two sets of parentheses, one inside the other. So we're going to go to the innermost parentheses first, that's here, and we're going to say that 2 plus 1 is 3. And we'll just bring everything else down. Get used to writing everything directly below what you're doing so that you can go back and review what you did and keep everything lined up and find mistakes. Now we've got one set of parentheses left, and inside that is 3 times 3, and that's 9. Bring the rest down. Now we just have addition. 2 plus 9, that's 11. Here's another example that has two sets of parentheses inside a bigger set of parentheses. There's an exponent here and some multiplication. So let's start with the inner parentheses. We'll start with this. 8 plus 7 is 15. Write it right below there. 5 times 3, 15. Okay. So remember to bring down everything, including the signs. Okay. Now we still have parentheses, so 15 minus 15, that's 0. Over here we could do these exponents now. 2 squared, there's a whole section on what that means, but that means 2 times 2, which is 4. Now we have some multiplication left, 3 times 4, so that's 12. And the final addition, 12 plus 0, 12. The associative property works for addition and multiplication, and it means that the terms can be grouped or associated in any way. It only works for addition or for multiplication. It doesn't work for a combination of addition and multiplication together, and it doesn't work for subtraction or division at all. Here's an example of the associative property with addition. You can see that on the left and on the right we've got the exact same numbers in the same order, but they're grouped in different ways or associated together in different ways. So we should get the exact same answer when we do them both ways. So we'll start with the parentheses here. 8 plus 2, that's 10. Plus 3, we'll bring that down. And the parentheses here, 9 plus 7, that's 16. Now we have all additions, so left to right. 10 plus 3 is 13, plus 16, 29. So over here we have it grouped in a different way. So we'll start with the parentheses. 2 plus 3 is 5, plus 9, that's 14. Bring everything else down. 8 plus 14 is 22, plus 7 is 29. And here's an example of the associative property with multiplication. Again, on the left and the right we've got the exact same numbers, 2, 3, 4, 5, and we're multiplying all of them, but we've got parentheses in different places. So starting on the left, we've got 2 times 3, that's 6 times 4 times 5, that's 20. 6 times 20 is 120. And over on the right, we've got the same numbers, just grouped or associated together differently. We'll start with the parentheses. 3 times 4 is 12. Bringing all this down. 2 times 12 is 24. 24 times 5 is 120. Same answer. The next property to talk about is the commutative property, and it means that terms can move around or commute. It also works for just addition or multiplication, not subtraction and not division. Here's an example of the commutative property for addition. We've got the same numbers here on the left and the right, but they're in a different order. They've commuted around, they've changed places. But we're going to work left to right, and we're going to come up with the same answer. 3 plus 2 is 5. 5 plus 7 is 12. And over here, 2 plus 7 is 9. 9 plus 3 is 12. And here's an example of the commutative property with multiplication. Again, we've got the same numbers being multiplied on the right and the left, but they're moved around in a different order. 1, 2, 3, 4, and 3, 1, 4, 2. But we should still get the same answer in the end. So working left to right, 1 times 2 is 2, 2 times 3 is 6, 6 times 4, 24. Over here, 3 times 1 is 3, 3 times 4 is 12, 12 times 2 is 24. The next property is the distributive property, and this works on multiplication and division. It means that when you have something in parentheses, addition or subtraction, and that in turn is being multiplied or divided by something, we can distribute the multiplication or division first before we do the addition or subtraction, even though they're in parentheses. Here's an example with the distributive property using multiplication, which should make it even clearer. First we're going to do it with letters, and then we're going to do the same example with some numbers. So here in parentheses we've got b plus c, and then a is outside the parentheses. Anytime you've got things next to each other like that without an explicit operation listed, it means that there's multiplication going on. So it's saying that we've got the parentheses, b plus c. We can multiply that first before we add it. We can do a times b, that's ab, plus, we keep the plus sign, and a times c, ac. So we should get the exact same answer. So here, on the left side, we're going to add the parentheses first, that's kind of our old way, and then do the multiplication. So 2 plus 3 is 5. 5 times 5 is 25. But with the distributive property, that says that we can do the multiplication first as long as we do it to both terms. So 5 times 2 is 10, plus, we still keep that sign, 5 times 3 is 15. So what we did is we multiplied the 5 times 2 and then the 5 times 3. We're adding those together. 10 plus 15 is 25. Here's an example of the distributive property using division. And we'll talk about fractions a lot in the next section, but the fractions mean that the top is divided by the bottom. So we're showing that division that way. And this shows, again, we've got some letters. We're starting with letters. B plus C, all divided by A. The distributive property says that's the same thing as taking the first one, B, and dividing it by A, and then the second one, C, divided by A. We keep the plus sign in the middle because we have a plus sign here. Again, let's do that with some numbers. So we have 6 plus 3 on top divided by 3. Well, we know that 6 plus 3, that's 9. 9 divided by 3 is 3. The distributive property says that's the same thing as doing this part of the division first, 6 divided by 3. Here, 6 divided by 3. And then taking the second part, 3 divided by 3. We add them because we have an addition in the original problem. 6 divided by 3, that's 2. Bring down the plus sign. 3 divided by 3, that's 1. And 2 plus 1 is 3. Another properties of numbers that's important is identities. Identities mean that there's a number for each operation that doesn't change its value. So for addition and subtraction, the identity is 0. You know this. 3 plus 0 is 3. 3 minus 0 is 3. And for multiplication and division, the identity is 1. You know this too. 5 times 1 equals 5, and 5 divided by 1 equals 5. In fact, anything multiplied by 1 is itself, anything divided by 1 is itself. People tend to zoom right past these properties without realizing how important it is. But both of these identities are going to be really important to the process of converting fractions to another format to have a common denominator. We're also going to use this to solve equations because we'll be multiplying by 1. Even if we do it in another form, it'll keep the thing it's having the same value. The last topic we're going to talk about in this section is factoring, and it really means to break down a number into its smaller components. You find the smaller numbers that multiply together to get the larger number. So here's some examples of factoring. We can say, what are the factors of 10? Well, you can start with a little bit of trial and error and start with 1, 2, 3. They have to be whole numbers that multiply together to get exactly that number. So 1 times 10 is 10. 2, let's try 2. 2 times 5 is also 10. 3 doesn't go evenly into 10. So we'll keep going. We find out that just these are the two combinations. So the factors we say are 1, 2, 5, and 10. So the same idea, what are the factors of 12? We always start with 1. So 1 times 12 is 12. 2 times 6 is 12. Let's try 3. 3 times 4 is 12. 4, well, we've already listed 4. 6 we've already listed. So again, here are the factors of 12. 1, 2, 3, 4, 6, and 12. Each number always has 1 is a factor, and itself is always a factor. So when we do factoring, we've already mentioned that 1 and itself are always factors of the numbers. But prime numbers are numbers that only have 1 in themselves as their factors. So things like 7, that's only 1 times 7, or 13, 1 times 13. Those are prime numbers. And again, why do we factor? It'll help us simplify fractions, it'll help us find common denominators, and solve equations. It's a great tool.